Hello everyone, welcome to Mining Devs. Today is a special day for all the participants in this lecture. We'll be covering practical examples of how you can use blockchain and how can you deploy a smart contract. So please share this link with as many people as possible, and this lecture will definitely be something that you guys will want to come again and again if you ever want a career in blockchain. On this note, let me introduce everybody. Harpal Jadeja. He's the special guest for today, and he's the developer relations engineer at Celo. Hello, Harpal. Finally, good to see you, man.
Good to see you.
Great, great. So, Harpal, over to you. We can start with the basic introduction, and then we can proceed towards the lecture. Please go ahead.
Sure. So the agenda for today for everyone is basically that we will learn about how wallets work, what is a wallet, and learn the Solidity language, the basics of the Solidity language, and then eventually deploy a project on the Alpha Oris testnet, which is the Celo testnet. So let's get started. If you want, you guys can also tag along. And the first thing that we will be doing is installing a wallet in a browser. So I'm going to use Chrome browser, and I'm going to install the MetaMask browser, which is like the most popular one. There are many other alternatives, but this one is like the most default one that everyone starts with. So that's why I'm using this as an example. So before installing this, maybe I would like to give a small explanation of why we need a wallet. So whenever you want to access blockchain applications, you need a private key and a public key. So let's say, for example, you want to use banking services, right? What do you need first? You need a bank account, right? And when you create a bank account, you get two things. You get bank account number, which you give to everyone else, and then you get a debit card pin or some kind of pin which gives you access to your own funds, like transferring funds to someone else, or any kind of transaction that requires your authorization. You would use that kind of pin, right? So that's how public key and private key are as well, right? Private key, as the name says, is supposed to be kept private, and you are not supposed to show it to anyone. Public key is basically address which you give to everyone. So whoever has the address can send you funds, and then you can receive it. So by creating a wallet, we are basically doing the same thing. We are basically opening a blockchain account kind of thing. Okay. So the URL to this wallet is metamask.io. You can search on Google, but I recommend that you type this URL directly because there could be some phishing sites with the same name. So if you can remember this URL, that would be great, like metamask.io. This is the URL. Depending on which browser you're using, it will prompt you to download for Chrome. It also has a mobile app, iOS, Android. It's also available for browser like Firefox. So I'm using Chrome, so it's gonna prompt me over that. When I click on it, it will take me to the Chrome store. Again, if you are searching for MetaMask on Chrome store, make sure that it has a lot of users and a lot of reviews, right? So that way you can verify that this is the original one. If I do add to Chrome, it will ask for some add extension. And once it starts downloading, uh, my screen is visible, right?
Yeah, it is visible, Harpal.
Okay, okay, great. Thank you. So once the installation is done, it will automatically open up the screen in your browser, which basically tells you, welcome to MetaMask and connecting you to Ethereum and decentralized web. We are happy to have you. So this is basically an onboarding, and this is like the first step to start your journey in the blockchain space. Like getting a wallet is like the first step. So once we get started, it will give you some tips on like it will ask you that whether we are allowed to collect some information about your clicks and improve your experience. You can say I agree or no thanks. Anything is fine. I'm gonna do no thanks. Then you get two options. Are you new to MetaMask, or did you have a wallet before? Right? So if you are new to MetaMask, you would create a wallet. But let's say you had a wallet before, and let's say you lost your laptop, or if it was on your phone, you lost your phone, or it broke down, then you can use the import wallet option and import the wallet. So since we are doing, I'm assuming that everyone would be doing it for the first time. then I would do create wallet. Once I do create wallet, it's gonna ask me for a password. This is a password that is going to be set for unlocking the extension. So anytime you close your browser or restart your computer and open the browser again, it will ask you for this password. This password actually has nothing to do with blockchain specific things. Okay, so let's say you type a password. For example, I'm going to just go from 1 to 8 right now, and that's fine because knowing this password can only unlock your extension. It's not like an account password. So I'm just going to click create here. The that password is useless if your laptop breaks down, right? When you do import, it's not going to ask you for that password again. It's just for unlocking the extension, that's it. Here is a small video on learning how to keep your secret recovery phrase safe. So, secret recovery phrase, I'm going to call it SRP from now on. So, SRP is basically a master key to your account. Using SRP, you can create multiple accounts. So, if you want more than one accounts for different reasons, like one account for accessing some particular kind of application, then you have a second account for a different type of applications, or you want to have separation of concerns, then you can create multiple accounts using the same SRP. So it's like a master key. If your SRP gets compromised, all your accounts will be accessible by someone else, right? So make sure you keep it very safe. And there is a small video here that you can watch for 1.5 minutes in order to know how to keep it safe. But if you ask me, the best way is to write it on a piece of paper and keep that paper safe. Obviously, create multiple copies of that paper and keep it in safe places. Don't keep it in the same box, right? Obviously, because if one of them gets wet or something, then both the papers are gone and you lose your funds. So I'm going to hit next. Now, this is the secret recovery phrase, right? SRP. Your secret recovery phrase makes it easy to back up and restore your account. That's what is asked when you do import. So the thing behind this is what is asked. When you click import account, you have to enter that and then it will open your accounts back. So the reason why you have to keep this safe is because even MetaMask cannot get it back for you. There is no like helpline number or customer support where you can like call and tell them, hey, my laptop is broke or my phone is lost and I don't know my secret recovery phrase because I did not write it on a piece of paper. Can you help me get it back? And the answer would be no. If they say yes, then it's definitely a scam because they can't do it, right? So never disclose this to anyone. Okay, I'm going to disclose it now in front of you because I'm going to throw it away. I'm not going to use this wallet after this session, but don't use this wallet for your personal use. Okay, when you create your own wallet, uh, write it down and also make sure that you're like not being watched by someone else. Okay, while you're writing it down. So what I'm going to do right now is just copy this and paste it in a different tab. So the reason why I'm doing this, I will just tell you in a second. Uh, Now you can do next. Now, even it says that remind me later to recover this. I highly recommend that you write it down right now. If you are going to use it for the personal cases, like if you're going to add real funds to it in future, if you plan to do that, then write it down. And creating wallet does not cost you money. So if you're just following this tutorial, that's fine. You can like uh, delete the extension and create a wallet again, and then you can use that for personal use in case you don't want to do it now. So I'm going to hit next now. Now it's going to tell you that please confirm your secret recovery phrase. Basically, did you write it down or not? Let's confirm that. So they give you those words back. We just have to place them back in order. So I'm just going to do that right now quickly. Like, okay. Once it's correct, the confirm button will highlight. And once you click confirm, it says that you have passed the test. You should now keep your recovery phrase safely. And these are some tips. And then you can like click on all done. And then you have your account, right? So this is like your gateway to blockchain. This is like everything because this is like your public key. So if I copy this and paste it, like it looks like this. So obviously this is not something that you can easily remember, but this is your public key. Okay, you can share this with anyone you want. Anyone who wants to send you funds, if they say, hey, I want to send funds to you, how do I send it to you? You can basically give them this address. Okay. So and we have ETH here because we are on ETH mainnet. I'm going to talk about networks in brief after a while. So like let's say on for now. But yeah, if I switch that on, you will see the other networks as well. Ethereum mainnet, these are like the default ones. You can add more as you please, and I'm going to show you how to add more as well. Then you have options to buy. This is like buying crypto using your credit card if you want. It's up to your choice. Select whichever you want in case you want it. This is the typical send. When you tell when you want to send it to someone else, you can send it here. Swap is basically converting your ETH to some other tokens that you want. So all of those features are here. So basically a typical wallet, right? Assets, it tells you about what are the other assets that you have in your wallet. Activity are the transactions that you have done, all of that. Now, if I click on this circle here, you will see that there is one account. When you click lock, it basically will ask you for that password that we entered in the first screen. Then we have create account. So when we do create account, it's not going to give you another secret recovery phrase. As I said, your secret recovery phrase is the master key using which you can create multiple accounts. So this is a second account that got created using your secret recovery phrase. However, the public key is different. Okay. So the public key for this is different. As you can see, it's E493. If I go to account one, it's 4966. And obviously the private key is also different. So how do you check your private key? You can go to this and go to account details and do export private key, and then enter the password that you entered before. 1 2 3 4 5 6 7 8. Yeah, so this is the like the private key. This is the private key and the words that we had, which is sometimes 12, sometimes 18, sometimes 24. The words that we got is the secret recovery phase. So that's how the wallets, like this is like a basic overview of how wallets work. And there is settings, you can check this out as you please. So this like the wallets. Now now yeah, the reason for explaining wallets before going into code is when you want to like deploy your applications, you have to pay some fees. And in order to pay the fees, we need some place to hold funds, right? And that's what a wallet is, a place to hold your assets. So that's why we created the wallet first. And now we can like jump into code and understand how Solidity works and then eventually deploy a smart contract. So, like, if there are any doubts, maybe this would be a good time to take any doubts related to wallets. Vinayak, what do you think?
Yeah, definitely, definitely. If there are some questions, guys, maybe you could unmute yourself and ask right now, or even if you want some questions, you can place them in the chat box, right?
Yeah,
So we can take them.
yeah, sure. If any question pops up, you can just dictate it to me in the chat box, Vinayak.
Definitely, definitely. I'll
Yeah,
lay them to you. Yeah.
thanks.
Yeah, there is one.
Okay, what is the
What?
difference?
Yeah.
Yeah. What is the difference between public key, private key, and wallet address and the relation to secret recovery phase? So, secret recovery phase, as I said, is a master key. And using one master key, you can create unlimited accounts. Now, for generating accounts, there is something called account derivation. You can Google it, like secret recovery phase, account derivation. If you type that, you will also get the process and the algorithm of how address is like private key and public keys are generated from your secret recovery phase. And the difference between private key and public key is that public key is your uh, a string of characters which you give to someone else. Okay, so if you tell me if I want to receive funds from you, then I will give my public key to you and not my private key, because using my private key, I can send funds to someone else. So if I give you private key, you can get access to my wallet and then send funds to yourself, right? So don't give your private key to anyone, not even to the customer support of MetaMask. Like there are people who would tell you that I'm calling from MetaMask. I've seen that there are suspicious transactions, or you might be compromised, and ask you for your private key. But don't do that, because nobody wants your private key. Nobody needs your private key in order to help you. Okay, so don't give your private key to anyone. And public key is something that you can give to anyone, because uh, if you want to receive funds, they need to specify something, right? that where should the funds go, where should the payment go to, then it would be a public key. Also using a public key, they can see your transactions as well. So it depends on you if you want your public key to be very public or not, because whoever has your public key can see all the transactions that has happened on your wallet, because it's blockchain, right? Open and transparent for everyone. Uh, yeah. What does the swap button do that was available in wallet and account? The swap button basically lets you convert assets. So if you have ETH in your wallet and you want to convert it to other tokens like BTC or USDT, USDC, that's when you use swap function. MetaMask takes some charges there, so it's up to you whether you want to use it. Basically, it's an aggregator. MetaMask checks for best prices on the available exchanges and then gives you a price which is best for you. And if you click swap, then it will convert your tokens from one to A to B, whichever you select. Great. Let's move on to code there. So this is editor. This is like an online editor that I highly recommend that everyone start with, to show you how it would look when you first visit us. If you go to it's the link is remix.ethereum.org. If you hit enter, this is how it looks. This is like an online editor for beginner people. Like if you don't want to go through setting up a lot of libraries and dependencies and you want to really get started directly, then this is like the best place to like start learning Solidity. And when you like come to this link, you will see that there is a file explorer here. If you hit this folder, you will see three contracts: storage, owner, and ballot. This to do one is something that I've created right now for the workshop today. But if you start, storage, owner, and ballot would be available for you. Then there are scripts for deploying these contracts, tests that you can write as well. So we'll go over all of this, but the best thing about this is that it's online, so you don't have to like face a lot of errors while doing the developer setup. So that is File Explorer. Then we have a search as well. Then we have this compiler. So Solidity compiler is basically here some things that might be out of scope or might be something that you might not understand, which is completely fine. And you can reach out to me if you want to. That the way we have compilers in our programming languages, like if we have C++, if we are coding C++, we have a compiler which compiles and then converts those files into binary. Similarly, Solidity compiler converts the Solidity code into EVM opcodes. Okay, so if you have done assembly, EVM opcodes look very similar to assembly language, and you can learn about them like by going to EVM codes. You will see a list of EVM opcodes, what they do, etc. So all of that Solidity code that we write gets converted into these EVM opcode statements, which is what the EVM understands. So if you have, let's say, done Java, then you must have heard about JVM. Similarly, there is EVM, Ethereum Virtual Machine. So that's where the compiler comes in between to for conversion of code. Then we have this deployer as well. This is like the best part of Remix, right? You can deploy your contracts right from the browser itself. You don't need to do complete developer setup and everything. Then we have a debugger as well. You can debug your contracts here. Then we have a plugin manager. You can install various plugins available here for additional features like contract verification, all of that. Then we have settings, and you can enter your grid credentials in order to like post the code on your GitHub and all of that. So let's jump into one simple contract and understand the Solidity language, right? So this is like the most basic hello world kind of project of Solidity, which is a storage.sol. And to let's go line by line and understand each line here, and like get to understand how all of this works. So the first line basically here is SPDX license identifier. Uh, don't worry about this term. It basically means that if your code is open source, what type of license you want to put on it, right? Because when your code goes open source, there are a lot of things. Usually you might have come across the MIT license, which basically means that open for all, use it as you please. But then there are other licenses as well, which have specific restrictions. You can check it out on Google. But this is all for like legal purposes and all of that. So usually it's MIT, GPL3, whatever. Like based on whatever your project is, you can check out the licenses and put the license here. The reason Solidity specifically does this because what happens is when we write code, we are expected, the developer or the team who developed the application is expected to verify that code and make it open for others so that others know what is going to happen when they interact with your application, right? So when your code goes open, obviously people can copy it, right? So if you put a license here, you can impose some rules on them that what you can do with this code, what are you allowed to do with this code, and if you come across few people who are misusing their code, you can legally take action against them if you have the proper license here in your code. Don't worry too much about it right now, but this is like when you do production level stuff, right? So do we have a doubt?
Yeah, I think there is a question by Ashmeet. Should we go for Rust
Rust,
or
sure.
Solidity?
Yeah. So it depends. Rust is for blockchains like Solana, Near. These blockchains have Rust-based smart contracts. There are maybe others as well. I am not aware of, but the most used language, like over 50%, 60, 70% is Solidity. So that's why I'm like going through Solidity code. But it depends, whichever is your weapon of your like weapon of choice, or like whichever is your favorite language, right? You can go with that. So Rust is for Solana and Near based smart contracts, and Solidity is for all the EVM based chains. So whenever someone says we are a blockchain and we are EVM based, then it supports Solidity by default. Okay. So yeah, to the code. This statement here basically means the Solidity compiler version that we are willing to use, right? Why do we have to specify a compiler version? Because every compiler has upgrades and new features. The recent one, for example, to give you example, a recent one 0.8.0 has overflow checking by default, right? So overflow basically means that if you are specifying that a number is supposed to be only positive and you do subtraction somewhere and it goes below zero, then it will give you errors, right? Which is good because it should give you error. If Because if it goes to negative and then some other calculation takes place using that number, then it will be incorrect, right? So this was not supported before. So depending on whichever compiler you want to use, you can specify this. There are signs here. Greater than equal to basically means that uh, this contract can be compiled by any compiler which is 0.7.0 or greater than that, but less than 0.9.0. Okay, that is one way of reading this. That these are the versions of compiler supported. Then you might come across another one which is something like this. Uh, this is a caret sign. Basically, it means that uh, to like in plain English, this would mean this contract can be compiled by any compiler which is greater than 0.8.0 but less than 0.9.0. Okay, so the middle number that has to be same. Other than that, this can be 1, 2, 3, 4, 5, anything. Okay, so that's what it basically means. However, when you go production level, many security people, the people who work in smart contract security, they uh, recommend that you lock your compiler version so that it can only be compiled by a specific compiler version and not by anything else, right? In order to make sure that it works as it's supposed to, because you did your work with the compiler that, like, you might have set your compiler version to 8.4, but you kept it like this, and somebody might compile your contract with 8.7, and if there is a small change, then their contract will work differently and your version will work differently, right? So they ask you to like lock your versions, and by locking basically mean that you don't put any kind of sign, just straight away put the number there, right? That's one way of doing this. So I'm just going to undo this here. So yeah, let's go to the next lines. These lines are comments. So this is telling that the title of the contract is storage. At the rate dev basically means this is a message to the developer that store and retrieve value in a variable. So this is like the objective of this contract. And then it gives you a script location, which is this. So like if you want to deploy this contract, this is the location to the script, something like that. So this is all comment. It has nothing to do with code. If you remove this, the contract will still work as it's supposed to.
Uh,
Um,
Shankar, is there any question that you'd like to ask us? Hello. I don't think so. I think we can go on.
yeah, okay, cool. So on line 10, we have this keyword, which is contract, and then we have the name of the contract. So the contract word here is a keyword, which means that you cannot use it for a contract name. So let's say you want to name a contract called contract. You can't do that because it's a keyword, right? Very similar to we have in other languages. So storage is the name of the contract, and by saying contract here, we are saying that we are starting a contract from here. From line 12, we have the data types. We start with data types. UN256. What does this mean? So let's break it down. U means unsigned. Unsigned means no sign, which means positive. Int is integer, so you can't have floating values, zero point 0.7, zero point 0.5, etc. You can't have that. 256 refers to the number of bits that it's going to occupy if in storage. So if you know the concept of bits, then 8 bits is 1 byte, 256 bits is 32 bytes, right? That's the storage slot size in EVM. So EVM has a storage, and every slot is 32 bytes. And that's why we usually go with 32 bytes numbers. Like this is like the default thing, but there are others. If you can also do unit 32, you can do unit 64, depending on your use case, right? You can do. And obviously the upper value, the upper bound of this integer also then differs. So the biggest value that you can put here would be 256 ones, right? In a binary. That's the biggest value that you can put. Again, here we have some comments about what the function here does. So basically, this is the function keyword. We are defining a function here called store. We have a argument or parameter called num, which will take in. Public here basically means that this function can be, this is like a function modifier, right? If you are familiar with other languages, you might have come across these modifiers as well. Public modifier here basically means that this function can be called from any function inside the contract or by any entity outside the contract. So any entity, I mean, it could be a wallet, right? It could be a wallet, or it could be another smart contract, right? Who wants to call this smart contract? So public basically means that you can call it from inside the contract or from outside the contract. And what does it do? Number is equals to num. So basically, number is a storage variable here. Basically, after every call, this value would be available for someone to read, right? So we want to store a number. So what we do is we pass in a number which gets assigned to this variable which is present here, and then it stays there on the blockchain, right? It's on chain stored forever, unless someone comes in and changes, obviously, right? Then we have another function which is retrieve, and basically it means that we want to view or basically see what the value of a number is, right? Now the difference between like obviously there are two different operations being performed here. One is a write operation. So a write operation, and this costs gas. Okay, this is not free. This is going to cost you some fund in order to do it. It's not free. And this is a read operation, right? We want to only read the value, and this is free. Okay, so this is free because we are just going to read it. We are not going to do any kind of like we are not going to occupy any extra storage or not going to change any variable already stored in storage, right? So that's why we have this additional uh, word here, or a function modifier which is called view, right? So view basically means that this function is only meant to read. So what if I try to read a value? Let's say I do number equal to 2 here, right? And if I go to this compiler and say compile, it will give me error, right? It says function declared as view, but the expression modifies the state, right? So it basically saying that you cannot modify values because you told me that you are only going to read in this function, right? So this statement is invalid. And once I compile it again, it goes back to normal, right? And what does this function return? The returns keyword basically is as a return here to say that this function is going to actually return something, and then in the brackets you can specify what you are going to return, the data type of the return value. And if you have and C++, we write int main, right? So this is like the return type for us. Similarly, uh, this is the return type for us in Solidity, and we are returning the number. And this return type and this is the same, right? So let's see how this looks if when we deploy it, right? So since we are in Remix, it's going to be just a few click of buttons. So the first step is obviously to compile. So if you would usually be here, all you have to do is go to this third icon, which is looks like an S, and hit compile. If there are no errors, you will see this green check mark. Once compiling is done, we can go to this Ethereum looking logo, which is the place for deploying. You can see deploy and run transactions. Now, you first option here is to select the environment. Now the environment here is Remix VM, which is Remix virtual machine. An Remix virtual machine is basically an EVM running in the browser. So this is like your local host kind of thing, but in the browser, which is online. Okay, so it's not like you can turn off your internet and also deploy contracts. It's not going to work like that. But it's a local machine just for you. It has nothing to do with the Ethereum transactions that are happening right now live. Okay, and the advantage of this is that even though you don't create a wallet, you get access to some wallets here given by Remix. There are like I think 10 or 12 wallets here given by Remix that you can use, and all of them have like 100 ether balance. Obviously this is all not real balance. These are just test values. For this is like a playground for you to test your contracts right before you go on the real blockchain. In the environments, we have Berlin, which is a different version. We have metamask as well. We can connect metamask here as well, but let's try with Remix because it's quick. So uh, the next thing, gas limit, we can ignore all of these for now. Gas limit, value, all of this, and jump to contract. If we open this, you will see that it will show you all the compiled contracts. So if you have compiled other contracts, you will see those as options here as well. But since we did only one, that's why we only have one option right now. And we can click on deploy. Once we click deploy, it quickly deploys it because we are using the Remix VM, obviously. And this is the console, and we can see a green check mark here, and it tells us about that the storage contract has been deployed. And we also get this section here which says deployed contracts, and we can see storage at, and there is some characters here. Storage at some characters. These characters is basically the contract address, right? So the storage contract is located at this address in the Remix VM. Okay, this address is not present anywhere else. This is only in your own browser virtual machine, the Remix virtual machine, which is running in your browser specifically. So it's only available for you. If we click on this icon here, it will expand and show us what all we can do with this contract, right? And all of this can be done using pressing buttons, which is the best thing, right? If you are just starting out, this is like the best thing for you. You don't have to like write a lot of code. Yeah,
Sorry to interrupt. Could you zoom in a bit?
yeah, sure.
Yeah. Yeah. Thanks. It's more visible now.
Okay, great. Sorry for that.
It's
So
all right. It's all right. Please go ahead.
yeah, so like this is how it used to look. Deployed contracts, storage at some characters, and this is like the address. This copy button will basically let you copy the address of the contract. But since we are on Remix VM, it's probably not useful because you can't access this contract anywhere else other than this tab itself. So as the function, the based on the functions, we get the buttons here. The color of the buttons also indicate something. The orange ones are going to cost you fees, and the blue one or the greenish one is free. Okay. So right now, if we hit retrieve, what will we get, right? We should get the default value of number because we haven't given any value and we haven't stored anything yet, right? So if we hit retrieve, we get 0, which is the default value for unsigned integers. Unsigned integers default value is 0. That is why we have 0 here. Now let's say I want to store a number 5 on the blockchain. I will hit 5 and do transact. This transaction will happen with in respect to this wallet. Okay. So wallet is required. No matter what you do, wallet is required. You can see that it says account here. For us, we can even call it wallet. Some people call it account. Different terminologies, but the meaning is the same. So you can use this account, you can use some other account, all of that, right? So let's see, and let's switch to the second wallet to show you that it actually costs us fees to do this. So when I do number 5 and do transact, it's going to happen immediately because we are in the virtual machine in Remix. So it happened immediately, right? You can see a green check mark here. Storage.store is the function that we called. All of that data which you can inspect here by clicking this icon. You will see a lot more details which might be out of scope for this session. So I'm not going to explain that. But if you are curious, you can click this icon and explore more. If we go up here, you see that when I started, before the transact hitting the transact button, it was 100. Now it is 99.99. Basically, some of the items were taken away from me because the transaction cost money, right? As I told you, write operations cost you gas and read operations don't cost you anything. So now if I do retrieve, it's going to give me 5, right? Because we just changed the number from 0 to 5. So that's like the basic contract on like the hello world contract basically of Ethereum or Solidity, sorry. So now let's jump into a more complex one. I have a more complex example. We have like 20 minutes here, but let's see. I will try to cover as much as possible. Um,
Uh,
yeah,
Harpal, there are some questions also.
yeah,
uh,
okay,
yeah,
okay, yeah. Let's take questions first then. Yeah,
maybe we can do quick questions a bit quick and then focus
yeah,
on the advanced sections. Yeah,
sure, sure, definitely. Yeah.
great.
Um. So okay, Rahul asks, I did not understand what is a modifier. Also, are there more modifiers other than public? Yes. So what a modifier basically means is what is your how accessible is your function. So if you say your function is public, which means the contract, for example, if I go back to code and the storage value, let's say I have another function here which could be like xyz and it wants to use store, right? It also takes in a UN 256 num, let's say, and then what it does is it basically does not store num, but it stores num into 2, let's say, for example, right? And if I so maybe I need to like let's say I call this internal. So what this basically means is that any function inside the contract, this function is inside the contract, right? Inside the storage contract, can call it, right? That's what public means. And the other additional feature is that anybody from outside the contract. When I'm using this section here, I am outside the contract. Imagine you are outside the contract, you are not inside the contract. And outside the contract, there could be two people. Either one who holds the wallet, it is which could be a human, and then other thing could be a contract because even contracts can talk to each other. Okay, so public basically means any function inside the contract can call it, and outside entities can also call it. The other access modifiers are internal, like one here I mentioned here. Let's say I want to use XYZ, right, in store. So let's say because store is, uh, let's say, yeah, okay, I can give you an even better example. Let's just compile this contract and let's see. I will show you a good thing. If I go and deploy, and if I expand this, you will see that we don't get a button for XYZ, right? The reason for this is because it's internal. It can only be called from inside the contract. Internal access modifier basically means you only the functions inside your contract storage can call XYZ. No outside entities are allowed to call it. And that's why you won't see XYZ button here in the interface, right? So that's what internal means. There is one more, which is external. So let's say I switch to external now and I save it, and I have to discard this contract. So one more thing that I forgot to explain you guys is that every contract is code is immutable. So when I make changes to this code, I have to go back, I have to compile again, and then I have to deploy again because the contract that is deployed is permanent. The code of that contract cannot be changed now, right? So every time you make a change, compile and then deploy again. Only then the changes will be reflected. Once I deploy, you can see that I got another instance here. And now you can see I have the interface for XYZ as well, like the button and the value, etc. Right? So external basically means you cannot call it from inside the contract, right? So if you try to call this function XYZ from any function inside here, it will give you an error, right? So let's say I do XYZ num here and I save it. It gives me an error, right? If I go here, it will tell me XYZ it not is not visible at this point because it's external only, right? It's not meant to be called from inside. That's what the external modifier means. And the last one is private. Private basically means that uh, no uh, no function inside this contract can call it, but uh, then the concept of inheritance comes in. For let's say a contract A is storage, and I try to do like let's say function ABC, and then I call XYZ here, and then I put in 2 and I have saved it, right? So it's giving me no visibility. Okay, just a second. Uh, Say this is public identifier, because this is not even visible for this, right? Because A does not can't get access to XYZ because it's private, right? So if you like go and learn more about inheritance, then you would like this is like very common in other languages as well. So if you learn inheritance, you will come across these kind of words: public, private, and external is new. External is only specific to Solidity. Internal might be called protected in some languages. So that's how access modifiers work. Uh, Gagan asks, a contract feels a lot like Java classes with attributes and function. Is abstraction and inheritance possible? Yes, everything is possible. Inheritance is also possible, and abstraction is also possible. There is actually something called abstract contracts as well. So you can even put abstract here, right? And then what you can do is you can have some functions implemented and some functions not implemented. So some functions to be implemented by the inheriting entity, right? Inheriting class, right? So abstraction is possible and inheritance is also possible. Sanskar Gupta says, what if we don't use view keyword in the retrieve function? Let's try it, right? Let's try it right now. So I'm just going to remove all of this code that I added. Let's remove this keyword, right? So it's going to give you first a warning that the function state mutability can be restricted to view. So it's basically in simple English. If I want to explain it to you, it's basically saying that you should mark this function as view because it's not changing any state. But let's say we don't want to do that. And so we compile it. And if we go here, I will discard this. Make sure you discard it every time because that's only how the changes will reflect. Deploy again. Oh, okay. I forgot to remove this. File again, deploy. So now it's deploy. And if we go here and do retrieve, it's not going to give us anything back, right? Because view functions are the ones who return values. Uh, the non-view functions or the right type of functions don't return anything back. Okay. So that's how it works. So view functions are meant to return back. And you can also see this by the color change, as I told you. Remix is very good with this. If I mark this view, let's say I mark it view again. I already told about to explain to you all this, but again, let's just do it again. If I deploy again, you will see that the color changes when you mark functions view because that's a completely different type of modifier, right? That's a state mutability modifier, you can say, right? View, and there is one more which is called pure. Pure basically means that you are not changing your inputs. You are not manipulating input values, the values that are coming in the functions. You are not manipulating them. That's what pure means. And then view, and then there is one with none of them. How do you define float values? We don't actually have float values. Rather, the reason why we have this is 256 bits is that we use bits to represent bigger values. So there are many other ways of doing float values, but it's like too advanced. There are libraries that are written in Solidity where you can handle float values, but by default, there are no float values in Solidity. However, what you can do is like if you go to the Solidity docs page, you can go to like if you let's say if you go to docs.soliditylang.org and go to types and value types, you will see all of these. Yeah, we have fixed point numbers. Yeah, I think we have floating points. Yeah, these are the ones. Sorry, fixed and you fixed. So fixed is like unsigned, fixed point, floating numbers, and then you fix is unsigned ones and fix is like the negative ones and all of that. So we have that as well. Float, double, all of that. Yeah. Sorry for that. I haven't probably used them till now, but yeah, we do have those as well. But you can, but this is like the encyclopedia of Solidity. Okay, everything that is written here is most up to date, right? And if you are referring to some resources, I highly recommend that you come back to this page and double check, because whatever it is written here is written by the people who have created Solidity. So obviously they are the ones who know the things most. And as I told you, that any code that you deploy is immutable, which means it cannot be changed once it goes on to the blockchain live. So you would want to make sure that is correct, right? And you understand each and every line of it. So that's why, just whenever you want to learn about types, this is like a good place to learn about all of these types. And there are many other warnings and notes in these sections, which are also extremely important, because there are many hacks that have happened and it has been found later that there was a note. If they had followed that note, then that hack would have been avoided. So before you read, like if you are interested and curious, you would want to go in and read each of the notes, warnings, and understand everything. There is one more question. If you want to modify any variable and also return, what to do in that case? So what you can do is, the simplest way that I can explain to you right now is that, let's say we want to, like, the best way obviously is like first modifying it and then retrieving. So your front ends can do it as you want, right? Like your front end can make a call to the contract and then change the value and then make another call to retrieve it. So that's like the easiest way of doing it. However, I haven't yet come across like a use case where you would, like change a value and then also like return it. The other way would be where there are two contracts, where one contract is making a call and then that contract itself is doing the uh, retrieve as well. So let's say, for example, there is a contract which is XY, which does store first and then it does retrieve as well, right? So that's how this, and then this function can like send out values to the caller, because contracts cannot call other contracts by like without any external entity. Whenever a transaction starts or any type of interaction starts, it's always a wallet, it's always a human. Human meaning, like, obviously it's a wallet, but it could be like server controlled or a human controlled. So uh, the end result will land up to that entity. It could be like a server which has a private key stored on it and then it makes transactions, or a human which clicked on a button, confirm button, then those people would be able to see those values. So that's one way of doing it. Mm. If we have any other questions.
I think we can move forward. Harpal, there is one more thing I wanted to add. If we can show them how to integrate Celo, that would also be good.
Sure, yeah, definitely. One thing what we can do here is like, let's say we want to, like, let's deploy the storage contract for now, right? That would be the best thing. What we can do is like if we install MetaMask, you will be able to like see it here. If you hit it, you will see that we are on Ethereum mainnet. What we can do now is we can start adding the Celo networks here into our wallet so that we can access the Celo blockchain from MetaMask. So this is a website. This is a good website called chainlist.org, where you can easily add networks to your wallet. There is a manual way of doing it. I can show it to you if you want. You can go to, you can click this icon here. You can go to settings and then go to networks and then add a network. And when you add a network, it's going to ask you all of this information. Now, this is a lot of tedious task. That's why someone came up with this idea of this website where you can easily add networks to your wallet. So it's very easy. You can also switch on this testnet and you will see the testnet networks as well. So what you can do is you have to just click on connect wallet. Let me just refresh. Connect wallet. It pops up your wallet. You can click connect. Once you're connected, you will see your wallet here. Now you can search for the networks that you want to add. Let's search for Celo and then add to MetaMask. It's going to request. You can see allow this site to add a network, Celo mainnet. This is the details of what it's going to add. This is basically the details that you're supposed to fill in the screen that I showed you. So approve, and then it's going to also prompt you to switch to that network. So let's say I hit switch, you will see that now Ethereum mainnet has now been changed to Celo mainnet, right? If I switch on this, you will be able to see the testnet networks. Test network is basically a network which is similar to the main network, but the transactions here and the contracts here are for test purposes. It's like a testing playground. So you can test it there for free, like using free funds, right? The fees that you pay, all of that is the same. But the funds you have when you are on a testnet network are free, are basically a mock network, right? And the mainnet is where you use real funds. So let's add the testnet network as well. Approve, switch, right? And now what we can do is there is a something called faucet. So if we go to Google and search for Alpha Horus faucet, you can ask for those test funds basically, right? So when you are deploying your, like when you are testing your contracts and you want to deploy them on the Celo blockchain, you would first want to deploy it on the Celo testnets to see how they work, and are they working, because Celo testnet is the uh, most close to mainnet version, right? It's not the same, but the feel of the the um, things that will happen with your contract would be very similar to one that will happen on mainnet. But here you won't be using your real money. You will be using some test money. So it's going to ask you for an address, basically a public address where they want where you want to receive your test coins, test Celo. So I'm just going to click on this and copy it, paste it here, uh, complete this captcha. Wait, okay. And once that is done, we can click on get started. And then in a few seconds, you will see that you will receive one Celo. It says that each request adds one Celo. So yeah, we got one Celo right. Now, what we can do is now we can go to our Remix IDE, right? And now switch the environment, right? Switch the environment to injected provider, MetaMask. And once we do that, it's going to request us to ask you which the account you want to connect, right? Because every account is separate. So it's going to ask you which account. So I'm going to do account one because I have one Celo on it. I'm going to click next and connect. Now I'm connected. It also shows my balance, one Ether. One Ether because Remix does not understand Celo and everything. So one Celo will be shown as one Ether here. Okay. Now let's deploy this contract. So it's the same. We have compiled it, so we don't need to compile it again. Now we can click on deploy. And when we say deploy, this time MetaMask is going to pop up, right? Because we are now going to deploy it on the Celo testnet, which is an actual network and not something which is local to your browser tab, right? So once I hit confirm here, it we can like view in our MetaMask activity that we actually did a contract deployment. If I click here, it will show me view on Block Explorer. Block Explorer is a place where you can view transactions. So it's not taking me to the right one, but the right one would be go to Celoscan, and in this corner you will see Alpha Orange testnet. When you click here, you will be able to search for contracts on the testnet. And now storage at this address is actually available. So if I copy this, go here and paste it here and hit enter, we will see an actual contract. It says 39 seconds ago, right? That's when we deployed it. And the transaction type was contract creation. So that's how you deploy contracts on testnet using Remix, right? This is like the easiest way to get started in the Solidity space. So we just basically deployed a contract. And if you go to this contract section, you will see that this is the bytecode. This is like your Solidity code converted into hexadecimal, right? So you can verify it. Once you verify it, what will happen is that the code here that is shown here will be visible here for other people to see. And Block Explorer is a place where people would go and search for the transactions and contracts and understand what am I going to interact with before they even start it, right? Like the savvy users, what they do is they if they know which contract address they're going to interact with, they put it on the Explorer and see what is the code. if I'm going to do something, what will be the result? What is it going to do? I hope it doesn't do something bad with my wallet, right? That's what you want to see. And if you click on this hash, it will tell you like what happened, who did the transaction, the from address. From address is basically the address here. You can see 4966. That's the same. And 2, it says the contract was created, and this is the address of the contract. You can click to see more, the transaction fees and all of that, right? So that's how you like deploy a contract on Celo testnet. Any doubts?
I don't think we have any further questions related to this. I think.
Definitely. Great. I think I'm already in the Telegram group as well. So in case anyone has any doubts, they can also reach out there.
Yeah, if you want, you can actually share that in the chat box as well, so that everybody can have a look around. Guys, please, if you have any question, you can stay connected to the community. If you have any questions related to building it, and what we'll suggest is that you should go ahead today and try to build a contract and try to do this process by yourself. This video will be available to you in a while, yes, and so that you can go ahead, go through this video again and try to deploy it for yourself, right? And if you have any questions, feel free to join the community, and we'll be more than happy to help you. So maybe we can share the links as well with them. Yeah.
Yeah, sure. Can you like share the Telegram group link that is created for mining devs?
Yeah,
That's the
definitely.
one, right? Yeah.
Yeah, we'll definitely share all those links with them. Yeah.
Yeah.
Yeah, that is something that after the lecture the team generally does for everyone here.
We also have Celo Discord in case anyone is interested in that. What you can do is let me just share it with this in the chat. If you want, you can go to this Discord link as well and connect with us in our own Discord where I will be present answering your questions.
Great. So I think on this note, maybe we can, end this lecture. It was an amazing lecture, Harpal. I don't know about everybody. Like, I think a lot of people, they actually enjoyed the lecture and the questions were really wonderful. The audience is really wonderful today. We hope to see everybody here again with a contract in their hands and, posting it like, "Oh, this is my first contract." We'll love to see that, right? And please do so.
Yeah, sure. Deploy a contract and tag Celo.
Yeah, definitely. We love that. Thank you, Harpal. Thank you for being
Thank you.
here. It was really amazing. Really amazing. I think everybody loved it. Thank you
Sure.
so much.
Thank you. Thank you. Have a nice day.
Yeah, you too. Thank you, everybody. Wonderful audience.